I'm going to present a couple of examples here to you regarding the Euclidean algorithm calculating greatest common divisors. What I'm going to do is I'm going to pose the questions. I want you to pause the video, have a crack at them and come back and check what you've done with the solutions I'm going to present. So here you go. Here are the three questions. 3 sets of numbers and 3 pairs of numbers. I want you to find the greatest common divisor of the first two, so it's 2 pairs to begin with, and then I've given you a trio of numbers for the third one. So think back to how we calculate those, have a crack, and come back and check. So I want to find the greatest common divisor to begin with of 56 and 6. Now remember, to do this, we use a division algorithm, we write it out, we then change our divisor and our dividend, using the remainders and the previous divisor, and then we keep working until we get a remainder of 0. So, let's set it up. Do we want 56 equals something times 6 plus a remainder? Think of your times tables. If I have 9 6s, that's 54. So I know it's going to be 9 times 6 plus my remainder, which is equal to 2. So there is a remainder there, which means I need to move on to my next step. Now remember, my next dividend becomes this part here, the divisor from before, and my new divisor becomes the remainder from the line before. So I want to write it in the format 6 equals something times 2 plus a remainder. Well, I know 6 is just 3 times 2. So in this case, it's 6 equals 3 times 2 plus a remainder of 0, which means my divisor here is my greatest common divisor of both numbers. So I can quite simply write that my GCD, my greatest common divisor of 56 and 6, is equal to 2. So they share another factor of 1, but the greatest common divisor they'll both share in this case is 2. Quite simple and straightforward. This example here, I'm going to look at finding the greatest common divisor of 93 and 7. So again, we want to start by writing it in the correct format. So a correct format, following the division algorithm, is 93 equals something times 7 plus a remainder. Well, if I think of my 7 times table, I know 7 times 13 is equal to 91. So 91, my remainder from that to get to 93, is equal to 2. Still have a remainder, I go again. This time though, my divisor from the previous one, my 7, that becomes my dividend. My new divisor is the remainder of the previous line, so it'll still give me the same format, all that's changed is the numbers. So 7 equals something times 2 plus a remainder, well it's 3 2's plus 1. We still have a remainder, so we go again. This time though, we're going to have it written in the format 2 equals something plus 1, something times 1, sorry, plus a remainder. So what times 1 gives you 2? It's quite simply 2, and there's no remainder at that point. Which means that there, my divisor for that line, is the greatest common divisor overall. So I can say, fine, that means my greatest common divisor of 93 and 7 is equal to 1. Yeah. One thing to maybe look for is when we get to this point and my remainder is equal to 1, we can safely say the next line is going to be something times 1 plus no remainder. That'll mean that our greatest common divisor at that point is equal to 1. So you can keep that idea in your head as you're working through these, because that'll happen. Final question I pose to you is the greatest common divisor of the numbers 40, 66 and 82. Now if we think back to the theory behind all of this, what I have to do is look at the greatest common divisor of each pair of numbers, and then I take the smallest of the greatest common divisors. That'll then give me the overall greatest common divisor of all 3 numbers. Doesn't matter which order you look at the pairs in, we just have to make sure we do them all. So I'm going to start by looking at the greatest common divisor of 82 and 66. So again, same steps. Format of the division algorithm, it's going to be 82 equals something times 66 plus a remainder. Well, it's going to be 1 times 66. My remainder for that is then 16. Got a remainder? We go again. This time though, it's going to be the format of 66 equals something times 16 plus a remainder. Thinking again of your times tables, I know that 4 times 16 will give me 64. My remainder is then 2. Still got a remainder? We can go again. I know this time 16 is going to equal something times 2 plus a remainder. Well, in this case, it's 8 times 2 plus a remainder is 0. So I can say find the greatest common divisor of those two numbers of 82 and 66 is equal to 2. So my previous divisor on that line. Let's select the next pair of numbers to look at. So let's stick with the highest one, the 82. And this time we're going to look at the greatest common divisor of 82 and 40. Now again, remember, it doesn't matter the order of the pairs that you look at, you just have to make sure you look at all three pairs. So in this case, I'm going to look at 82 being something of the format, something times 40 plus my remainder. Well, in this case, it's going to be 2 times 40 plus a remainder of 2. We go again because the remainder isn't 0. This next line are going to be of the format 40 equals something times my previous remainder, which is 2, plus a new remainder. Well, I know 40 is equal to 20 times 2 plus a remainder of 0. So that there, the 2, is my greatest common divisor of those two numbers as well. So my greatest common divisor of 82 and 40 is equal to 2. Now, it's looking good at this stage that the greatest common divisor of all three numbers is going to be 2. The last pair we're looking at is 66 and 40. The greatest common divisor of 66 and 40. Now, they're both even numbers, so we know 2 is going to be the greatest common a common divisor, sorry. We just have to prove whether it's the greatest common divisor, or we have to look and see if there's another one as well. Still, follow the same set of steps. 60 is equal to something times 40 plus a remainder, a standard format that we're looking at. Well, 66, we know is going to be 1 times 40 plus a remainder of 26. Still a remainder, move on to the next line. Same standard format, the only thing that changes is our dividend and our divider. We then find a new quotient and remainder from that. So 40 is equal to something times 26. Well, in this case, it's going to equal 1 plus a remainder of 14. Still a remainder, we still continue. Now, in this case, 26 is going to equal something times 14 plus a remainder. That's the format we want. Well, it's going to equal 1 times 14 plus a remainder of 12. Still a remainder, we still continue on. I know in this case 14 equals something times 12 plus a remainder is what I'm after. Well, it's 1 times the 12 plus a remainder of 2. Still a remainder, so we still continue. Although it's looking quite good right now for the 2 being the greatest common divisor at this point. You could logically think like that, because I know 12 is equal to 6 times 2 plus a remainder of 0. So there you go. My divisor at that point is 2, so I can safely say the greatest common divisor of those two numbers, 66 and 40, is equal to 2. Well, it's worked out quite nicely, because the greatest common divisor of each pair of numbers has ended up being 2. So I can say, fine, therefore the greatest common divisor of all three numbers, so 40, 66, and 82, is going to equal 2. So the greatest common divisor of all three of those numbers is 2, because it's the smallest of each of the three greatest common divisors. However, all three greatest common divisors actually end up being the same thing anyway, which is quite nice and quite lucky. These steps, using the Euclidean algorithm, allow me to find greatest common divisors quite quickly, easily and straightforward. You just have to remember the standard steps that we're looking for, the standard format we want to put the numbers into, and how we work with the division algorithm and apply it to these sorts of scenarios.